anything specific. Everyone has read the question? Everyone is familiar with the assignment question? Yeah? Have you started doing the first part, which was the energy analysis? Yeah. No? Some of you haven't? Maybe you started. So, we can go through the first question. How about that? And for those who have done it, maybe you can just cross-check what you need to do. I mean, that step 1, you can do that at the end. That's just introduction, literature review. You can do that on your own. But that part, energy analysis. So the whole idea is there's only one energy source that's going in, which is diesel. And what do we want from that diesel? We want electrical output, but we also want thermal output. Normally in the industry, that part is not there. It's only diesel generator. So you supply diesel, you get electricity. Industry doesn't care about, most of the times, about the waste heat that is going out. But as we're going into the future, with fossil fuels basically getting expensive and it's not environmentally friendly, we have to make it more sustainable. So we are capturing thermal energy from the coolant, we are capturing thermal energy from the exhaust, we are trying to heat up water. Okay? Question gives you mass flow rate of the water. So you've got that Excel. Has everyone opened the Excel? No?
Yes.
Yes? No? Some of you yes, some of you no, maybe. I think it was up there somewhere. Which is your demand supply, that Excel.
So can I take a video?
Oh yeah, go ahead. I don't mind. Just don't post it on YouTube, please. I'm not even very nice. So that Excel, okay? Has everyone downloaded the Excel? No? You have a laptop, you don't have a laptop. That's okay. So the basic idea is you enter your student numbers, last 2 digits, and what you get is a load profile. It gives you how much flow rate of water is needed, how much electricity is needed. Okay? So if I go back to that, that's a very good schematic. There. So it gives you how much mass flow rate you need every hour for the entire day, and how much electricity you need every hour for the entire day. So that's an average value for hour given. In the industry, or let's look at your own household. When you're at home, and if you look at your water consumption and electricity consumption for 1 hour, is it constant? No. You go to the tap, you open it up, close it. So the flow goes high, low. So what's given is an average for 1 hour. There might be fluctuations. In real world, you will find those fluctuations. But for assignment, academic purpose, what I've done is said, okay, average is this much for 1 hour. But the next hour it increases. The following hour it decreases. Again increases. So what you need to do, you're getting that water from some local water source, local bore, which is coming in at 20 degrees Celsius. You want to heat up that water to 85 degrees Celsius. Okay? So if mass flow rate is given and you know the temperature difference, would you be able to find how much amount of thermal energy you need to heat it up? What kind of equation are you going to use? These are simple energy balance, first law. So mass flow rate is given, and don't be scared of answering. Give a wrong answer if you don't know, but give an answer. I mean that will at least help you participate. So if you have got mass flow rate m dot, you have got change in temperature, original temperature 20, you want to heat to 85. So temperature change is known. You've got mass flow rate, temperature change, and what else you need? CP, specific heat capacity of water, right? So that will give you the total amount of thermal energy needed to heat your water from 20 to 85. Now, what are we going to use? The question says we are going to use waste heat from the diesel generator to heat up this water. There are 2 streams of waste heat that we can easily capture. from coolant and from exhaust. There's one more stream of waste heat from the engine, which is just the body gets hot and the heat radiates out to or convects out to the ambient. We cannot capture that. Very difficult to capture that. So there's a catalog for diesel generator given. There. In that catalog, I'm going to just click on that and open that for you. Sometimes it takes time to open that. There's a column which talks about waste heat in form of radiation, radiation heat loss. Okay. Can you read it at the back? Yeah? So, that column, radiation heat loss to the surroundings in kilowatts. That value in that column, we cannot use that for heating water. So in the first part of the question, which is the energy balance, this is of no use, but you would need that for exergy analysis to find exergy destroyed. Okay? And we will talk about exergy tomorrow. So when everyone has got a laptop. Okay? Energy is a lot easier. We can discuss energy today, we can discuss energy tomorrow, we can discuss basically all different topics. Now, what I want to use this time for, my and your time, is not to really give a lecture, but rather to help you on specific things, because I can see just that each one of you is at different stage in the assignment, right? So it's not going to help if I just keep talking. Rather, you start working, and then where you get stuck, Abhijit, you can call me Abhijit, okay? So I'm your course coordinator, associate professor Abhijit. No need to call me doctor, professor, just call me by first name, Abhijit. Difficult to pronounce, just call me Abhi, okay? You can call me and just ask me, which equation to use here? I'm lost, what do I need to do from here? And I'm very sure there will be one more person in the class who is stuck and at the same point. And that's where I can say, anyone else who is looking for, and then we can, just in 2 minutes, I can explain you, and you can continue working in a group. Okay? Although it's an individual assignment, there's no reason you can't work in a group. This is how industry works. When you work in the industry, you're working on a big project, you're working with some other colleagues. Sometimes, I mean, you don't make them do your job. No one is going to do your job, but you can always ask them. Okay? You think everyone is here, or we're waiting for a few more? No? Maybe 2 more minutes, and then we'll start with the real today's topic. So that is the radiation heat loss that we need to use for this exergy destruction. But what about that? Cooling system heat rejected to the engine coolant. So that amount, that value, we need to use it in the first part of the heat exchanger. You remember the heat exchanger part? Where we had as the coolant heat exchanger, water coming in at 20 degrees Celsius, goes to exhaust heat exchanger. And then comes out at 85 degrees Celsius. So that's your generator, diesel generator. 85 degrees Celsius out of the diesel generator, back into the diesel generator at 35 degrees Celsius. Q dot is given in that column. Okay? So that amount of Q dot, if you knew how much amount of Q dot is going in, you know mass flow rate of water, you should be able to figure out that temperature. Because you see that Q dot, what we are assuming all the thermal energy that is given by the coolant is being absorbed by water. That's one of the assumptions written in the assignment. Assignment asks you to make that assumption. Okay? So you've got a heat exchanger, hot water is flowing through the heat exchanger, cold water. So hot coolant is flowing through the heat exchanger and cold water is flowing. They're transferring thermal energy in between them. What we are saying is whatever thermal energy coolant loses is received by water. That's to simplify, and that's how you start your analysis whenever you're doing modeling. When you work as a thermal engineer, for example, in the industry, I assume everyone is working somewhere as a professional, right? I don't know anyone does thermal analysis, thermal design in their job, no? But there's so many companies they need. A couple of my students in Melbourne, they're working at a company called Black Magic Design. Black Magic Design. So it's not a Black Magic company, but what they make professional cameras. Like it's a competitor for Nikon and Panasonic movie cameras. And mixing kind of, they've got a 10-channel mixer, like 10 cameras are there. Imagine a live news is going on or some live show is going on. Someone is sitting on the background, or let's say a soccer match is going on. Which angle to project or to show on the television? Who decides that? That is basically the director of that show. And they've got this box, they go camera 1, 2, 3, 4, it just keeps switching. And even that box consumes 2 or 3 kilowatts of power. And that electronics needs to be cooled down. Someone needs to cool down. Electrical electronics engineers, they don't have any knowledge of how to cool that down. You have you done heat transfer course or you're doing it now, right? Or maybe some of you are doing it now with Kia, or maybe you might be doing it in the future. The heat exchanger. So all of these are connected. This course and cooling that down is a big thing. And there's a big market. All undergraduate students, they're working in these companies. What they do, their job is to design heat sinks and select appropriate cooling fans for different size. And that's just one example. Anyway, so this can be used. Now, in this case, you've got mass flow rate from, where do you get mass flow rate from? I'm going to pick someone and see whether where do you get that mass flow rate?
The question states it, right? Does it?
Yeah, in that Excel. Okay? And that's connected to your student number. Okay? Where do you get that Q from? From that column. But you can't just randomly select any Q. There are so many different models. Has anyone already selected a model? Diesel generator model, no? You selected one of them? Now, what do you need to do to select that model is, for every hour, what you have been given is, for example, time, different times. I'm just going to say 1, 2, 3, 4, number of hours. So that might be 5 p.m., 6 a.m., 9 a.m., whatever time in that Excel that I've provided you. And you will have mass flow rate for every hour. So that m dot is changing every hour. And what we want to do, we want to heat up water from 20 degrees to 85 degrees. So for every hour, how much thermal energy do we need? What's the rate of thermal energy supply for every hour? That m dot for 1 times Cp of water times delta T. And what's that delta T? 85 minus 20. Yeah? And that will give you kilowatts, which is nothing but kilojoules every second. If you use mass flow rate in kilograms per second, if you use mass flow rate in kilograms per hour, it's not kilowatts. Okay? So maybe I'll write that here. That's kilograms per second. You want to take a picture? Anyone? Okay? Now, you do that for every hour, and then now for 1 hour, let me, rather than drawing on the other side, I will draw it on this side, okay? So, you've got kilowatts, you want to convert it into kilojoules. every hour. What are you going to do? Multiply with 3600. Whatever number you get here, that number multiply that. Everyone with me? You do that for every hour. Do a sum of Q for the whole day, right? That will give you the total amount of thermal energy you need. Now, you can use either that value, total amount of thermal, you will have to use that total amount of thermal energy to figure out if your diesel generator is capable of supplying thermal energy. One first initial step, I think that's what you might have done when selecting, you might have looked at your peak. A lot of times I've seen students looking at how many kilowatts, right, for every hour. What is the peak? You look at peak, let's say it says 20 kilowatts is the peak. So will the first generator be enough? That's 13.6, and plus there will be some heat lost in the exhaust, which is not given directly in kilowatts, we have to convert it into kilowatts. Okay? How would you convert that into kilowatt? Again, you know, you have to convert volume flow rate of exhaust to mass flow rate first. M dot of exhaust times Cp of exhaust. You assume Cp of exhaust to be same as air. Specific heat capacity at constant pressure of exhaust, you assume it to be as air. Constant as well, 1.005. So M dot of exhaust times Cp of exhaust times how much temperature difference? Exhaust is coming out at what temperature? 455 degrees Celsius. There is a rule though, in the question is given that, I mean, in theory, what you can do, you can cool that down to ambient temperature, to 20 degrees Celsius. But as a rule of thumb, you should never cool down exhaust gas below 110 degrees Celsius. Why? Because exhaust from fossil fuels, diesel, petrol, natural gas, coal, which are hydrocarbons burning at very high temperature, what it does, the nitrogen from the air gets oxidized and you get nitrous oxide in the exhaust. Also water vapor, because there is hydrogen in the hydrocarbon, which is petrol, diesel, everything has got hydrogen and carbon. So you get carbon dioxide, oxygen from the air reacts with carbon dioxide, carbon gets carbon dioxide, oxygen in the air reacts with hydrogen, gets H2O, water vapor, and oxygen and nitrogen, which is within the air, reacts and you get nitrous oxide. So these are the three main components. Now moisture, water vapor, if you cool down the exhaust to 20 degrees, what's going to happen to the water vapor? It will condense into water droplets, and the nitrous oxide, NOx, you have, that dissolves in the water to create nitric acid. And nitric acid will start corroding your heat exchanger. Everything will be rusted. Not immediately, not in 1 second, but after 6 months, you have the whole heat exchanger is destroyed. And you don't want that. So as an engineer, what you will do, you will put a control system. You're going to control the temperature. You're going to say, even in the theory, when you calculate, you're going to say, we're going to cool down that exhaust from 455 to only 110. That's the lowest we can do. So delta T is 455 minus 110. So delta T multiplied by mass flow rate you get from the exhaust times Cp of exhaust gives you the amount of thermal energy in the exhaust. So thermal energy in coolant plus thermal energy in exhaust, if that sum was greater than the peak, most likely that generator may be suitable. Likely suitable. It's not a confirmed suitable. That's the first step of saying, okay, maybe this is suitable, maybe it's suitable. And the next step will be then to do that sum and comparing that sum. If you are operating that diesel generator, let's say MP12, MP14, one of them, or any one of them, if you're operating for the whole day, will it be able to generate enough thermal energy? We need to cross check that. Make sense? Now, definitely, I mean, I'll stop here because I need to cover new topic, and you don't have, most of you, or some of you don't have laptops. Tomorrow, please, everyone, please bring your laptops, right? And we'll spend significant amount of time, because I can see a lot of you are lagging, you haven't even started. I think it's due in, let's see, I don't remember when it's due.
End of the month.
End of the month, okay. July. Okay. But yes, you're working. If we can finish whole assignment by Saturday, I think you're going to enjoy the rest of the month, right? That would be nice. Because you're here, I'm here. You can start asking me questions a lot. I think couple of you emailed me for assignment 2. Must have replied to most of you, but I think I didn't reply to one of your second emails. One of your class, someone, I don't remember the name.
It's me.
It's you. The second email I did not reply back, sorry. Because I got busy with something and the due date is gone already. So, anyway, so what equation are you going to use? M dot Cp delta T, that's the most important. So can you, by tomorrow, I know most likely you're going to work tomorrow, right? Whole day? No? Maybe spend some time, 10-15 minutes, either when you go home today or tomorrow before you come to the class, 10 minutes or 5 minutes. If you're taking a train on the lap, open up that Excel. Just give yourself, if you haven't even opened the assignment, a brief introduction to yourself. So when you're here, you can immediately connect with what I'm saying. Okay? Okay, let's start with today's topic, and we'll continue with the assignment if you have questions after the break, or whenever we feel like you want to do something. Okay? You can start doing hand calculations as well today, not a problem. So, engineering economics is something that Raj hasn't covered, but it's not that difficult. A lot of times we engineers, what we do, we don't care about economics. What we care about, whether it works, whatever do we design, whether it works or not. And it's okay as an engineer to have that kind of attitude, but then it gets difficult when you want to convince someone to get money. Let's say you want to convince your boss that the project I'm working on is fantastic, it's going to improve, make so much improvements, it's going to create very novel kind of a creative machine. And the boss says, how much profit is it going to make? I don't know. And says, okay, good. I don't want to give you any funding. So what we need to figure out is really pay back. So what you need to convince your boss, if your boss is going to put in $100, how long will it take for whatever work you're doing to pay it back? I'm investing $100. Tell me how long it will take to return that $100 back. So that's simple payback. And then there's a real payback. So we'll start with simple payback, then go to real payback. How many of you have watched the lecture recording on economics? Anyone? No? I think Raj has already published those. I know you're busy, so the reason I want to know how basic I should start with. I think I should start with basic. Right? Yes? Okay. So these are the things that we are trying to hopefully learn by the end of these slides. We'll solve problems as well, and it will help you understand things. So we'll be able to define simple payback, and then life cycle costing, present value, future value, and present worth factor. Sometimes it's just called present worth. And don't get confused with, anyone has done economics course before? Maybe sometimes in high school, some students take some economics, money-wise or commerce, no? Never? Okay. So, Simple payback is really very simple. Okay, let's use an example. Everyone has done renewable energy. Are you doing renewable energy course?
Yes, I've done.
You've done it with Stefania and Chandra, Dr. Chandra, right? Okay, so you know solar panels. Okay, let's say we get a solar panel, and everyone knows what's the use of solar panel to produce electricity. Okay, so let's assume each one of our households consumes 1 kilowatt hour every day. Okay, very small amount of electrical energy really. Maybe on average we might consume 3 or 4 kilowatt hours. But let's say 1 kilowatt hour. And we buy a panel, we plan to buy a panel that will be able to supply 1 kilowatt hour every day in Singapore. Okay, now can anyone tell me how much it costs for 1 kilowatt hour in Singapore? Anyone of you pay your bills? 20 cents? 30? 30?
23
Okay, let's round it up to 30. Is now in Melbourne till 30th of June I was paying 23 cents. On 1st of July it went to 35 cents. So 23 to 35 just jumped so much. That's a big jump. So not just me, everyone in Australia is now paying 33 to 35 in that range cents a kilowatt hour. So let's say 30 cents for a kilowatt hour. And in a year, let's say you consume 300 kilowatt hours, not 365. Let's round it up to 300 just to make it easy. Okay? So 30 cents per kilowatt hour, 300 kilowatt hours, about $90 worth of energy you consume. Now to buy a panel, let's say, which can supply a kilowatt hour a day, is going to cost you $500. Okay, it's going to cost you $500. So once you put that $500, buy the panel, you install it. Now you don't need to pay electricity bill anymore because your solar panel is supplying all the electricity. Let's assume don't worry about day and night, battery storage, all of that stuff you've studied in. Make it simple for us to understand. So how long will it take for you to recover the $500 you've spent?
Around 2 years.
How will you do? About
2 years.
About 2 years?
You say 300, 500 days.
No, 300 kilowatt hours at 30 cents,
Oh, 30 cents.
which is $90 a year, or 5.5-ish years, right?
Yeah.
So 5 to 6 years. It will take 5 to 6 years, and that becomes a simple payback. It's really a simple payback. So you put $500 today, invest into panels, and next 5 years you don't need to pay. You're not paying anything. You're recovering. After 5 years, you recover all the money you've spent, and after that 5 years, everything is free. Okay, but that's simple payback. What happens to the real payback? Now let's say you have got $500 today. Instead of buying a panel, you put that $500 in the bank, in a fixed deposit, a term deposit. What happens? Will you make any money from the term deposit? You'll get maybe 5% interest, 4% interest. I don't know what's in Singapore. In Melbourne now these days, maybe 4%. Yeah? You don't know. Anyway, but you'll get some interest, right? In economics terms, that interest, that everyone understands what's interest, right? It's also referred to as discount. It's a completely different concept, right? When we say discount, it's something, it's cheaper. But discount is used, that term discount is used synonym for interest in economics. So ask any accountant, if you use the word discount, they think interest. Anyway, so that's just the definition. So if I use word discount, it means interest. Remember that. So interest is something that you gain. Now, everyone knows what's an inflation. What's meant by inflation? Inflation, you know, things become costly, and these days, or in the last 1 year or 2 years, things are very expensive. Everything is becoming expensive. Inflation is so high. So what does that do to your dollar, really? You have $500 today in your pocket. You keep it in your pocket. After 1 year, would you still have that $500? Let's say you haven't spent the money. You have that let's say $100 notes of $10, $50 notes in your pocket, you haven't spent that money. After 1 year, you still have those $10, $50 notes, but do you still have the $500 value to them? Huh? So today you could buy certain services, certain goods with those $500. After 1 year, you won't get the same services, same goods. But why? Because those services and goods would be more expensive. Whereas the value of that dollar would have stayed the same. Or, in other words, the dollar would have devalued because of the inflation. And that's what happens. Dollar devalues because of inflation, whereas because of discount or interest, it gains the value. So now the play between inflation and discount, and inflation and interest, how they're interdependent, and that's going to influence your real payback. So this is your simple payback. In a very ideal world where there is no capitalism at all, this will work perfect. Dollar today is still a dollar in 100 years and still a dollar in 1,000 years. That's not, but that's only back of the envelope. So you're doing some quick calculation. Yeah, approximately 6 years it will take, or 5 years it will take to repay. But when you start adding interest and inflation, the real payback will change, and we need to figure that out. Real payback. So up to that is clear, right? Simple payback. Maybe we can quickly solve this problem for simple payback, and it will make it clear. Which I'm giving you an example, but I will just quickly read through it and show you the solution. In a remote hotel, 5 kVA petrol generator provides 4,000 kilowatt hours of electricity per year for domestic or guest rooms and other load. The engine generator set on the average uses 1 liter of petrol for every kilowatt hour produced. That's kilowatt hour of electricity produced. The owner has been approached by a wind machine supplier who offers him 2 kilowatt aero generator for the total installed cost of $12,000. Okay? Considering the local annual wind conditions, the characteristics of the aero generator, the machine will have a capacity factor of 0.15. Now, what's meant by capacity factor? If you remember from renewable energy, a 2 kilowatt aero generator, when installed, will produce 15% of its total capacity, basically, right? It's because wind is not constant. Wind won't flow 24/7, 365 days a year. So throughout the year, what you do, 2 kilowatts times 365 days or 360 days times 24 hours a day, that will give you total kilowatt hours if that the aero generator will produce if wind was blowing constantly for 365 days every hour. But that's not the case. So you apply then 0.1, you multiply that number with 0.15, that will give you the maximum amount of electrical energy that aero generator will produce. Okay? Make sense? So if the aero generator is installed, in how many years will the fuel saving pay for the cost of the machine? Assume the fuel cost of $1.30 per liter. I mean, that was, I think I designed that question in 2021. Now the fuel cost is gone 180 in Melbourne, 1.8 ish. So, but anyway, so let's find total amount of electricity that aero generator can produce. Okay, so installed power, which is 2 kilowatt, times the power capacity factor 0.15, 24 hours, 365 days. That will give you the total, basically, kilowatt hours every year that this aero generator will produce. Okay. Now, cost of electricity produced by electrical generator. Okay. So, how much is going to cost to produce electricity if you're using electrical generator? The cost is for every liter is $1.3. So, if aero generator is installed, how much are you going to save? So it's $1.30 every kilowatt hour. You're going to save that many dollars. Make sense? if aero generator was installed. Now, payback period, how much does it cost to buy this aero generator? $12,000. Alright? It costs $12,000 to buy the aero generator. And the question says, it's the way it's simplified is that this aero generator will be enough to supply the power for that particular remote hotel. That's the consumption basically, equivalent to the consumption. So, simple payback will be, in about 3.5 years, you can easily recover the cost. But real payback will be different now. So, is that clear up to that? Okay. So, maybe I'll go a little quicker and skip few things. So, there are a few more examples, but what we'll go first try to think of is it just the cost of the aero generator? Is it just the cost of the solar panel, the previous example I gave you of $500 that we have to worry about? Do you think there's any additional cost in the real world? Maintenance, yes. Maintenance will be there. You have to think about maintenance. What else? So we have talked about capital cost, which is the original. Then operating cost, such as fuel. Sometimes maybe you need fuel, but in this case, in case of PV panel, you don't need fuel. In case of aero generator, you don't need fuel. But if you are planning to get a diesel generator or petrol generator, because we are not saying that you will never use a diesel generator or petrol generator. When we are talking about engineering economics, you might come in the real world, you might end up using a generator that uses fuel. Okay, so fuel could be one of the costs. This is a generic definition, very generic definition. Interest charge. We are thinking there could be a scenario where you don't have enough money to buy that aero generator. You don't have $12,000 to buy the aero generator. What are you going to do? You're going to borrow money from a lender, from a bank, and they're going to charge you interest. They're going to charge you service fees and all of that stuff, extra. All of that we have to consider. Maintenance, there's also insurance. Then is salvage value. So let's say solar panel, do you think it will last forever, ever? Aero generator, will it last forever, ever? No. What do you think is an average or typical life of most of the machines? Anyone can guess?
25 years.
About 25 years. Yeah, that's reasonable. 25, 30 years. But then, does it mean after 25 years the panel will not work? Will it stop working all of a sudden? It might still work, but not that efficient. So, will it have any salvage value? Like you want to get a new panel, a brand new, very efficient panel, but the old one, what are you going to do? Just put it in the rubbish? You could, but then it's going to cost you because government or someone, local authority will charge you for recycling it or taking care of it. You can't just throw it on the side of the street. Olden days, but that's destroying the environment, right? So someone you have to pay to get rid of it, or you might end up selling it to someone who needs it. So it might have a salvage value, or it might cost you to get rid of it. You have to think of all of these things as an engineer when you start designing things, and it's start to end, and that's life cycle costing. And it can get complicated. And as an engineer, you don't need to do that alone. You will consult a lot of other people. Okay? Because no single person would be able to have all that knowledge unless you have like 25, 30 years of experience working in the same field, and basically you know everything of your workplace. Most likely you're going to be the general manager of that. By that time you will be promoted so high because you know everything and you're master of everything. And then most likely you don't even need to make decisions. You'll hire someone to do that job. But anyway, so let's look at some more interesting facts. So when you're doing economic analysis, what we have to look at is a term called present value. So That's an explanation. We start with, let's say, $100 today. Let's consider $100 today. This amount of money would be after 1 year, if you put that in the bank, whatever interest, let's say it gives you 4% interest, bank gives you 4% interest, after 1 year it will be $104. Okay? After 1 year, whatever, that D is the interest rate. 4%, 0.04, so 1 plus 0.04, so 100 times 1.04, $104. Okay? As simple as that. Everyone follows that? So that D is interest. So that's interest. On the other hand, as I explained you earlier, inflation will be devaluing your dollar. So we value the worth of the money we have after 1 year. So after 1 year, you have got $104. You've got the interest, $4 interest on the bank. But not after 1 year, that $104, is it worth $100 from the past? Or is it worth only $50 from the past? Or is it worth $200 from the past? I mean, it might. Inflation might be positive, negative. Now, most of the times we have seen, at least in my life, I've never seen a negative inflation. Maybe even previous generation. There was a point though. I think not in Singapore, not in Australia, in Japan in 2016, after GFC, global financial crisis. Do you remember 2009? Anyone of you? What happened? It was terrible. Japanese economy was one of them. There were few other economies where bank was not paying any interest. You put money in the bank, they will start deducting money from you. They were not paying interest, they were taking interest. We'll keep your money safe, but you pay us $1 every day. Inflation went negative as well. For some glitches in this. Which means, basically, if inflation goes negative, things get cheaper. And it feels like things are heading in that direction right now. I don't know about Singapore economy, but Australian economy, that's happening right now. Till last year, for example, in real estate market, in property market in Australia, anyone who has bought $1 million property last year, 2020, at the beginning of the year, now it's worth only $800,000. So, inflation, although the reality, the inflation is going high, it's only for the commodities. Inflation is everything is getting expensive, commodities. Real estate has gone down. Not in every region. I mean, if you go to the heart of the Sydney or part of Melbourne, yeah, nothing happened, but some parts. Now, so that part, what we need to do is to find the real worth of that money, you have to divide $104 by that, and that G being the inflation. And therefore, the worth of $100 today will be 100 times the interest rate divided by inflation rate. I mean, 1 plus D is nothing but we are converting because it's in, D is in 0.04, 0.05, it's percent, 4%, 5%. Everyone understands math side behind it, okay? I hope. If you are not following, please ask. As I said earlier, ask me a question. Give me an answer. Answer is wrong, that's okay. Ask me a question. If you feel it's dumb question, still ask. Because I believe there's no dumb question. Because for you, if you're asking that question, you don't know. Seriously, I mean, in reality, you don't know, and I'm here to teach. So, that equation, maybe write that down. We will need, if we are planning to solve one problem, we will need that. Okay, or take a picture of those two equations. So, first equation is talking about future value of the present amount. That free is the sum of money today. So if you have $100 today, how much will its value be? How much would that $100 be worth after n number of years? After 1 year, 2 years, 10 years, 100 years, if the discount was that much, inflation was that much. Now, again, here what I'm trying to do here is simplify the equation. An economist, if you go to an accountant and an economist and you show this equation, they will say, yeah, it's correct, but the assumption here is your discount rate or the interest rate is constant for all those 10 years. Your inflation is constant for all those n number of years. In reality, we know they fluctuate. Okay, so you'll have to do kind of a running average or running sum in reality, but we don't need to do that. We are not economists, we are engineers. The reason I'm teaching you this only bring you to a point where you can start communicating with accountant, with the finance people, right? I hope you don't end up going into finance. You still do what you're trained for, design things, make new things, innovative, creative things, which then someone will figure out how much it's worth and how much it should be sold for, how much profit they're going to make, and they keep paying you very high salary, 6-figure salary, right? That's the target. So, and the other one is converting. If you had, in future, you hope to have $100, what's it's worth today? Is making sense what I'm saying? Is anyone getting lost? If you are, everyone knows what's meant by present value. Dig into your pocket or your purse, whatever money, that's the present value. Now think of, if you hold on to that dollar after 1 year, can you buy the same things that you can buy today for that dollar? That's the future value, whatever. Okay. So let's look at this example. Now it's again a simplified example. A car costs $30,000 now. What will be the cost of the same car in 1 year time if the inflation rate is predicted to be that 4 plus 0, where x is your student number, last digit. But let's say x is 0. So let's just say 4%. You can solve that afterwards if you want to on your own with your own student number. Okay. So let's say it's only 4%. X is 0, so the interest rate is 4%. Can you tell me how much will be the value of the car? Can you do that? Quick calculation. You have taken a picture of the equation. It was not the one of those equations though. It was whatever was in the text. I just want to see what we are trying to find. Anyone? Number? Have you got a number? So you've got $30,000 and there's a 4% inflation after 1 year. No one? No?
31,200.
Yeah, 31,000. Just 4% of 30,000. Okay? Are you following? 4% of 30,000, you add on to it. And so what we are saying, after 1 year, so you've got a product today. So in some cases, it's called hoarding. Sometimes suppliers, what they would do, they will hold on to some products and wait till 6 months or a year because the price will, so they will buy cheaply today from a manufacturer, hold on to it, after 1 year you make more money. But then if it's a technology product, you lose money, big money. Why? Because within 1 year technology has gone up and it's devalued really, because you can buy now more advanced technology. But you could hold on to things which don't change. For example, can you give me an example of something that would not change in its value?
The land.
Land,
Raw material.
raw material, maybe ore, iron ore, things, gold. Today's gold is tomorrow still gold, right? It's not going to change. Today's iron ore is still tomorrow iron ore. You only need to store, so the cost of storage you have to think of. Now, today's petrol is tomorrow's petrol. The only catch is it's going to evaporate. Also, there's a shelf life for pure petrol. If you're buying crude oil, that's a different thing. Unprocessed. I mean, that's what Singapore does so much processing, right? And selling of crude oil. So, I don't know the industry here, but this is what I've heard. A lot of money is made because of processing of crude oil. You buy crude oil, you hold on to it. It's not degrading over time, but you refine it slowly as the price goes. I mean, that's a good thing. So, for car, let's assume that's the case. Let's say car is not going to, the technology in the car is not going to change after 1 year, which is not true though. After 1 year, you'll get so much advanced car. The current car, today's car, which was $30,000, will be worth nothing. Maybe $10,000. You'll be lucky to sell it for $10,000. 1 year old car. Just exaggerating it, but maybe $25,000. Old car, last year's car. Have you gone maybe a car sales agency? If you go there, there's a end of the year clearance. Last year model for $5,000 less. Why? Because they know if they don't sell it today, it will be $10,000 less tomorrow. So they give discount and just get rid of it. So, okay. So, what will be the price of the same car in 10 years? I'm not going to make you calculate this. I will just show you. So, it will be worth 44,000. We are saying technology is not changing. Okay. And then, another example, a person deposits $10,000 in the bank, the bank pays interest rate of 2.5%. How much money does the person have in the bank after 1 year? Simple. If a person leaves the money in the bank for 10 years, simple. Okay? There's just maths. Logically, I think everyone is clear with the logic. Right? You put the money in the bank pays you interest. I can see a lot of you are tired, but I'm hoping you're following it. So, same logic goes in this example. What it says, no need to calculate, just quickly go through it. Let's say grandfather wants to deposit enough money in the bank, and I would be happy to have such a grandfather, really, that his grandson, who is now 5 years old, will be able to buy a car when he becomes 18 years old. So someone puts the money in the bank. Now, the car now costs $25,000, so the same model, but in the future, right? But not the same exact car. What's the most famous car model here? Or anyone drives a car? No? Toyota, which one? Corolla? Yeah? Okay, let's say Toyota Corolla, hatchback. Today, after 13 years, so 5 years and 18 years, after 13 years, still that grandson wants to buy Toyota hatchback, but the newest model, okay? Newest model, not the old model, the newest model. So we have to apply inflation, because if you want to buy newest model, that's another thing about inflation. Inflation is not just making profit. Why is inflation there? What's the other reason for inflation? Because technology is improving, services are improving. Because today's Toyota Corolla might not be self-driving, after 13 years might be self-driving. So there's extra services, extra potential in that, hence it's inflated. So the question is, and the question gives you, if the money that grandfather puts in the bank now gains an interest of 1.9%, and the inflation rate for the car is predicted to be 4%, which is the current kind of scenario. Inflation high, interest rate is low. Inflation at present maybe about 5.6 to 6% inflation right now, and interest rates are about 4%. So a little bit low, about 2% less interest rate. So how much money should the grandfather put into the bank today? That's the question. So what do? We first find the cost of the car after 13 years by applying inflation of 4%. That's what going to be the cost of the car. after 13 years, and that let's assume that inflation is purely due to technology improvement. Okay, let's not worry about what might be the reasons behind the inflation, but we get a brand new car after 13 years. It will cost you $41,000. Same model, Toyota Corolla. Now, grandfather needs to put enough money in the bank now such that the interest rate gain should be basically that same value should be equal to that. Okay? So that's what we do. We equate that value, what we get, future value of the car, equal to present value that the grandfather needs to put into the bank. How much money should be put into the bank? If that money was gaining an interest of 1.9% for 13 years, that will be the break even. Are you following me? That's the break even. That's the future value or worth, future value of the money. This is the present value of the money. And you're gaining 1.9% interest over 13 years. And the question is to find P. So just rearranging that equation. So today, grandfather needs to put in $32,000 in the bank. Okay? Now, let's do a quick mental exercise. Let's say each one of us, we grow old, we grow grandfathers, grandmothers, and then our grandchildren we want to buy. We are one of those very generous people. We want to buy something for our grandchildren, right? A car. And we are in a dilemma. Should I buy a $25,000 car today, or should I put $32,000 in the bank? Which one is cheaper? Oh, 25 is cheaper. So let's say I buy a brand new Toyota Corolla today. Get it from the showroom, park it in the garage, lock the garage, cover it up in the back, and wait for 13 years. My grandchild grows older from 5 years to 18 years now. On their 18th birthday, I said, do you know, I've got a brand new car for you. I open the garage and I say, this is your car, that's your present. What? It can't even self-drive. I have to drive this? Oh, it's still brand new, look at the polish. It will still be brand new, right? No one has used it. But what's happened? It's still old. So, would you put 25,000 in buying a car, or would you put 32,000 in the bank? That's a question back to you. What do you think would be wiser? A wiser one of you, I think someone would say, not give anything to the grandchildren. Just enjoy with the money. Let's think hypothetically. That's why I'm saying we're generous. For a second. We'll put the money in the bank. That would be the right thing to do, right? But I'm trying to connect and make you realize present worth, future worth. Is that clear? Present worth, future worth, and how inflation and interest can play tricks with the money and with your mind. Because someone without that knowledge would think, $25,000 is cheaper than $32,000. Let's buy it now. But the car is devaluing. On the other hand, though, if you buy $25,000 worth gold today and put that gold in a locker and give that chunk of gold to your grandchild, it's going to be more worth, definitely. And your gold will still have the same shine, right? So, there are things that you can do, you can't do. I hope you're going to make a lot wiser decisions in the future when it comes to investing money. As an engineer, you should start. Anyone who invests money in stocks, banks, commodities now, start thinking. Don't try to put a lot of money. Start thinking. Start playing around with $10, $20, just as a experience. But stock. I mean, if you're not expert in that area, don't put that. That's really like sometimes it can be a kind of gambling. Don't gamble. Put the money in the bank. I think most of you must have some savings, right? I'm dreaming about buying a house or an apartment or a flat somewhere, or maybe moving to Australia. I'm buying a big mansion there. I don't know. I dreamt of that now. Couldn't afford. Anyway, so what we did, if we use that equation, that the picture you took, right? So although we are putting this $25,000 in place of F, that's the future value, right? To get the present value of that future value, basically. Okay, so I'll skip through that and skip through that as well. These are just examples, and I've gone through in the recorded lecture. I've gone through this in detail. So if you really are interested, you might have to watch now 10 or 15 minutes of my video, which is on Canvas. So these are just examples. What I want to do is show you the next. Yeah, that's the topic, which is present worth factor or present worth. Now, that term is very useful. It helps us estimate the real payback period. Okay? And you tell me when, I mean, this might take another 5 minutes for me to explain, or maximum 10 minutes, not more than that. When you want to take a break. It is 8 p.m.? Yeah, maybe most likely. And then we can solve the problem after this. So, present worth will help us estimate real payback period. Now, this topic is important from your fourth assessment. Not just present worth, but the whole economics, engineering economics. But this part, the previous equation, which was P was F times one term divided by another term, that and whatever we're going to do. Because one of the questions in the fourth assessment would be thermodynamics based, for example, a heat exchanger or from a diesel generator. We are recording thermal energy from a diesel generator, for example. Or the topic which was taught just before this by Raj, which was on psychometric, yeah, with HVAC, air conditioning and humidity and all of that stuff. So let's say at your workplace, or let's say in this building, we have got old air conditioning system. Do you know how this air conditioning system works? Anyone has any idea? Are there individual air conditioners up here in the roof? No. There will be a central air conditioner or a chiller. Most likely a chiller. What it would do, chill water, make cold water, and then water gets supplied through pipes. And close to somewhere within the room or within the ceiling, there will be a heat exchanger where cold water is flowing and a blower is blowing air past it, and that cold air is coming in. Most likely. Okay? Now, let's say that chiller room, where the chiller is nothing but a refrigeration cycle. You remember vapor compression, refrigeration, like a compressor, evaporator, condenser, expansion valve. You have done the first thermodynamics long time back, most likely. That refrigeration system is there. And that might be 20 years old refrigeration system, let's say. It might still have another 5 or 10 years of life, but its performance might have started degrading. Energy cost is going high, electricity is getting more expensive. So it would be nice to consider, and that might be one of your jobs as a consulting engineer. So maybe you're working for a consulting engineering firm where they've been hired by the property services of this building or the owner of this building, and you have been assigned a task, figure out how we can save on energy, how we can save on electricity cost. And within this big project, people have been assigned to do a lot of things. Some of you may be looking at how we can reduce electricity from lighting, changing from these to LEDs, can cut down the cost a lot. But then one of you, let's say each one of you as an individual, imagine you've been assigned a task to cut down cost on cooling and heating of this building, HVAC, heating and cooling of this building. That's your task. How are we going to reduce the cost? And you start investigating. You look at the windows, how thick they are, how much heat gain is there from are they facing south where the sun is a lot of times? I mean, you being on the equator, it doesn't really matter, very close to the equator, Singapore. Whereas in Melbourne, we always have sun on our north, being in the southern hemisphere, And if you have plenty of windows on the north, in winter time, it's brilliant because we get a lot of sunlight and we need less heating inside. But in summertime, can get very hot with all that window. So then we need some eaves on the window to prevent, because sun is quite high in the summer, whereas in the winter right now it's close to the horizon. So on the window, on the top of the window, if we put eaves, then that stops the sunlight directly entering into the room. Things like those. So those are energy saving measures for heating and cooling. Let's say you've done all of that and now you're focusing your effort on the compressed, like the refrigeration system. And you decide, now we need to replace that refrigeration system. If we can replace that refrigeration system, you have done all the thermodynamics behind it, you're going to save so much cost. Not so much energy. And now your boss says, okay, how much is going to cost and what will be the payback? What will be the real payback? So your assessment 4, one of the questions, I'll make it simple. Question will be simplified, not that complicated, but the story will be that behind it, might be behind that, saying, okay, I've given you a table, you have to figure out a few things, find out the cost, find out the amount of energy that's being saved. I'll give you the cost of the energy every kilowatt hour. So how much will be the simple payback, or how much will be the real payback? You figure it out. Okay? It's going to be closed book, closed notes in class, face to face. This time around, everything is no more online. That's what Kaplan has told us. No more online. So, but I will provide you a list of formulas. Yes. List of formulas will be given. What I might even do, maybe tomorrow I will share the list of formulas with you. How about that? I have still not given the final list of formulas for printing, but then if you feel like, if you want me to add anything to the list of formulas, I mean, more lists, more formulas, that's okay, I don't mind. It's just that if we say open book, open notes, I don't know how it's going to become managed, because I won't be. But list of formulas will be there, and it will be quite straightforward. So let's look at present work. So let's fuel cost of the fuel. Let's assume that a petrol generator consumes 2,000 liters of fuel every year, and the cost of fuel is $1.30 every liter in the first year. So just the cost of the fuel in the first year is $1.30. Furthermore, it is speculated that the fuel price will rise at a rate of 10% each year. So every year it will increase by 10%, and it will increase at 10% constant every year. Okay. If the discount is 12%, which is interest rate, is 12%. We need to find the present value of all the fuel consumed over the period of 15 years. So this petrol generator consumes 2,000 liters every year. What are we assuming? We are assuming next year, second year, it will still consume 2,000 liters. After 10 years, it will still consume 2,000 liters. It's not going to degrade its performance. So we are assuming the petrol generator performance is constant. Okay, real world, it will start degrading. It will need more fuel to produce the same amount of electricity. But let's try to simplify to understand the concept of economics. So that's what 2,000 liters every year it will consume. The cost of fuel will continuously increase every year by 10%, and the interest that will be there, the discount value or the interest will be 12% every year, constant. Okay. What we need to estimate is total amount of fuel that this diesel generator, the value of the total amount, present value in 15 years. Okay. Now, let's forget about this question for a second and the numbers over there. I will tell you why we need to do this for a second. Okay. So let's say you're driving a car to work every day, and in a year you consume 2,000 liters of petrol. Okay. Today, cost of petrol is $1.30. Tomorrow it will be $1.31. When I say tomorrow, it might be after a week. After a month, it might be $1.33. Prices are increasing. We know prices of fuel are not going to decrease. They might fluctuate, but the moving average will be always tending up. Right? It's never going to go down for petrol. So you know, after 1 year, in the next 1 year, you're going to consume 2,000 liters. Today's cost is $1.30. Why not just buy 2,000 liters, put it in the backyard in a tank, and as we need, just fill it in the car and drive a car. You're going to save some money, right? That's the logic. But we're not going to do that. We're going to only estimate how much will be the cost. So if I buy it now, and if I buy it as I go, the difference between the value. Basically, what we are trying to figure out here is the present value of all the fuel I'm going to buy in the future. Now, the reason why we need to do that, the example of car is different because a car is something that we use at a personal level. But let's say it's a business expense. So let's say you start your own business, right? Some kind of a shop, a machining shop. Let's say you've got some CNC machines, and you know that CNC is going to consume a certain amount of kilowatts of electricity to produce a certain amount of product. And that's the base, like it's a base load. You need to spend that much money for electricity to make a certain number of products. And only if you make those products, you're going to make income, and that's going to feed you and your family. That's it. So you need that minimum amount of electrical energy, constant supply. Now, let's say you've got a magical machine and you can buy all the electricity and store it in some battery, magical battery, for the next 10 years. But that's not possible. We know that, right? It's not possible to store that much electricity. Say, fuel, we can store the fuel, but can you store 2,000 liters times 15 years in your backyard or somewhere in your factory for 15 years? The fuel will degrade. It will evaporate. It's a valuable commodity, so you need to hire a security for 15 years to look after it. Someone will come overnight and steal all that fuel. Right? That's a lot of fuel. 30,000 liters of fuel, that's a lot. So there are risks in that. Rather, what can I do? Because the whole purpose of me holding the fuel is securing my energy future. One of the ways to secure the energy future will be, okay, rather than me buying the fuel, is there any way we can estimate how much amount of money do I need to put in the bank today, assuming, making some assumptions that it will continue to gain interest, fuel prices will continue to rise, but I would have enough money in the bank that I don't need to put anything out of my pocket anymore for the next 15 years. If I just continue to withdraw money as I need to pay for the fuel, by end of 15 years, I will have $0 left in the account, and I would have been able to buy fuel every day or every month or every week, whatever that might be, but it would be sufficient. So what we need to find is what's the present value of all the fuel. So how much money do I need? I don't need to put all of that money in the bank today, but I need to estimate for the next 15 years how much money I'm going to spend on my fuel. Because when you start a business, you can't just think about what are you going to do after 1 year. If you think about after 1 year, most likely you're thinking after 1 year your business is going to fail. Right? If you think about 1 year only in advance for any business, that's definitely a failure because you're not thinking about long term. You have to think about future. So let's figure out how much. So first year the cost of the fuel will be $2,600 if we buy 1 year fuel today. Okay, all of that fuel was bought today. It will be $2,600. Now let's say what we need to do then over 15 years, all of that fuel over 15 years, what we're doing this, you see, that equation looks like a geometric progression series, right? Every year. And so that becomes the main equation, present worth factor. So take a picture of that equation, please. And that's simple as, you see, on the right hand side of that equation, that term there is no present value, future value in there. It's only discount and inflation, or interest and inflation terms only, relationship between. What it gives us? A factor. That equation gives us present worth factor. Once you get that number, you just multiply that number with that number, which is present value for the first year. What you will get is the present value for the entire 15 years of you. Now, another way of using this is now let's say rather than saying here. That ratio, capital cost divided by savings, what is that? What does that tell you, that ratio? That was the first thing we just started talking about today. Yeah. Simple payback. That's the simple payback, right? Now, how would you get a break even? Because if you want to find real payback, okay, if you want to find real payback, a break even will be that ratio, which is a simple payback, equal to present worth factor. When you equate that to present worth factor. So what is that? That's that big equation. Okay? That equation goes in there. What is that? That's simple payback. That's simple payback. So, capital cost divided by savings, that ratio, when we equate that ratio to our present worth factor, what we would end up getting is, this present worth factor is a function of what? It's a function of discount, inflation, and N. We know what is discount, everyone, it's interest. We know what is inflation. Now, what is N? N is number of years, but it could be real payback, or N could also determine how much should be the minimum life of the system. So you're buying, let's say I'm buying this pen for a certain amount of money, right? And what should be the minimum life of this pen so that I will get a break even? I'm going to make some savings by using a pen. I mean, I'm just saying a pen as a tool. I'm going to make some savings. It's a better pen than the older one. I'm going to save something, right? Or this new refrigeration system we were talking about in this building, the water chiller system. You're going to change with a new one, and it's going to save you energy. The solar panels are going to save you energy, right? So to get a break even, so how much should be the minimum life of that system? That N can tell you minimum life if you don't know minimum life or the life of the system, or it can tell you, if you know the life of the system, then it can tell you, okay, how much should be the discount. So one of these three could be an unknown. In your problem solution, you might not know what's the discount rate, or what should be the discount rate. You might not know what should be the inflation rate, limiting inflation rate. So these will be, one of them could be unknown, or one of them could be unknown. Because why we are developing everything, converting concepts into equations, is we want to estimate things, right? So, almost done. Basically, from in this question we know inflation of 10%, fuel cost is going to increase by 10%, interest of 12%, and we want to find for 15 years. N is already known. So we know all of these. We know G, D, and N, and so we get a 13.03. You multiply that with 2600, and that gives you your present value of the future fuel that you'll consume or you'll use. This is a little tricky concept to understand. So what I want you to do is spend 1 minute kind of thinking about this and ask yourself whether you really understand this concept. If not, let's make a little bit of discussion. We have got a couple of minutes before 8 and we can take a break after that. I can see some of you are already falling asleep. And that's normal. We worked whole day. Is everyone clear with? No? That's okay. Maybe you take a break, come back, eat something, get fresh. When you come back, maybe then you can think. Okay. So 15 minutes or 20 minutes? What was the normal? 30. Ooh. I mean, you take 15 minutes break or about 20 minutes, come back, and then we can take a break here in discussion. That way it will be at least a fruitful. We won't discuss, I won't show you any more new equations. No new equations, guaranteed. Okay?